This is Mr. Anderson for Kellogg Community College for Statistics Math 130. Today we're going to be looking at a problem on page 267. So, whoops, hold on. Gotta get this pen right. Page 267, problem number 1. And if you follow along, it says here, from past experience, a company found that in cartons of DVDs, 90% contain no defective DVDs, 5% contain one defective DVD, 3% contain two defective, and 2% contain three defective DVDs. And we're going to find the mean, variance, and standard deviation for the number of defective DVDs. So the first thing you should do is to make a table. Now your X are your chances, and your P of X is the probability that X would happen. So the first part of the problem, it says, a company found that in cartons of DVDs, 90% contain no defective DVDs. So there's a 90% chance that you will have no defective DVDs in that carton. Now, in terms of one defective DVD, there was a 5% chance of that happening. Of two defective DVDs, there was a 3% chance of that happening. And then 3 defective DVDs in the entire carton would be 2% chance of that happening. You'll notice that all these percentages add up to 100%, and here's your chart. Now what we're going to do is use the formula to find our mu, which is the average number of defective DVDs, and that expression is going to be to find mu is to add up all of the x's times p of x. So you have to take all of your chances of x happening and multiply it by the percentage of x happening, and that will give you your answer for mu, or the average number of defective DVDs. So we're going to go 0 times 0.90 plus, that's the sigma part here, we're going to add these all up, 1 times 0.05 plus 2 times 0.03 plus 3 times 0.02. And if you add up all of these numbers, you get a total of 0.17, which means that there are 0.17 defective DVDs per carton, which is good because you actually don't want you don't want a lot of defective DVDs, so you'd have to get a lot of cartons to get to one of these. So that's pretty good here. Now what we're going to do is we're going to find the standard deviation. Now, to find the standard deviation, what we have to do is use this formula. It's the sum, but in this case we're going to have x squared times p of x, and then we're going to subtract mu squared from that. Now we're going to use this mu squared from our previous problem here, so the setup is going to be taking 0 squared times 0.90. Whoa, little light pen slip up there, plus 1 squared times 0.05 plus 2 squared times 0.03 plus 3 squared times 0.02. Now, if we do that, we're going to get an answer for this equation if we type that into the calculator, and then we'll subtract our mu squared, which is going to be 0.17 quantity squared. And what this is going to give us is this is going to give us our variation, which is 0.321. Now, one other thing I would do here is take the square root of this, because that will then get us to our standard deviation. So the square root of 321 thousandths is going to be roughly 0.567, or roughly half a DVD. So that means that our standard deviation of our defective DVDs is within half of this, which is good because that means we'll go between, it's going to be normal within 67% of our cartons are going to be between 0 and 1 of defective DVD per carton. Now I'm hoping there's a lot of DVDs in these cartons because that's still some pretty good variation there with this setup. But that's how you do problem 1 on page 267. Thanks for watching.